Let's think about cybersecurity for a minute. Not as some boring technical thing, but as this high-stakes game, a strategic game of cat and mouse that's happening right now inside our computer networks. And really, understanding the rules of that game is the only way you can even hope to win. For years, the old way of thinking about security was basically like building a castle. Strong walls, a deep moat, and you're good. But let's start with a question that changes everything. What if the bad guy isn't outside trying to get in? What if they're already inside the walls? That one little assumption, well, it flips the entire strategy on its head. Because if you assume the attacker is already in your network, you can't just sit around and wait for an alarm to go off. That's way too late. This is where the defender's first move comes in. It's a whole new philosophy, really, called threat hunting. At its core, threat hunting is exactly what it sounds like. You're not waiting for a security tool to tell you something's wrong. You are actively, proactively searching for threats that have already slipped past your defenses. And it all operates on that one powerful guiding principle: assume you've already been compromised. And this right here shows you that huge shift in mindset. A reactive defense, that's just waiting for an alert, a broken window, a tripped wire. Threat hunting, though, is totally different. It's hypothesis-driven. The hunter starts by asking, okay, if an attacker did get in, what would they do first? And then they go looking for the tiny clues of that specific behavior. So, look, if you want to be a good hunter, you have to understand your prey. So let's switch hats for a second and look at the attacker's playbook. Once they get inside, their number one job is to make sure they can stay there. They have to survive reboots, logouts, anything that might kick them out. This whole idea is called persistence. One of the absolute simplest, most common ways for an attacker to get persistence is using something called run keys. They basically just add their malicious program to a special list in the Windows registry. That list automatically starts up every single time a user logs on. It's so simple, but it is incredibly effective. And right there, that's where the hunt begins. As a defender, you'd start scanning these startup locations, and you're looking for those telltale signs. A program with a totally random-looking name, one that isn't digitally signed by a known company, or maybe an application that's running from a weird place, like a temporary internet folder. Okay, another favorite technique is to hijack the system's own scheduler. Attackers can create a task that just tells the computer, hey, run this malicious program every morning at 9 a.m., or run it every time someone logs in. They're literally using the system's own tools against itself. So the hunt for this involves digging through all those scheduled tasks. Defenders are looking for anything that just feels off. Tasks created by strange user accounts, tasks that are hidden from the normal view, or ones that execute these really confusing scripts instead of a program you'd recognize. Now, this next one is really clever. It's called DLL hijacking. So think about a normal program, like your web browser. To run, it needs to load all these little helper files, called DLLs. What an attacker does is create a malicious DLL, give it the exact same name as a real one, and then stick it in a folder where the browser will find and load their malicious version first. So how do you hunt for this? Well, you have to watch what a program is loading right when it starts up. You're looking for that one suspicious moment when a trusted application, like Windows Explorer itself, suddenly loads an unsigned, fishy-looking DLL from a place it has no business being, like someone's downloads folder. Okay, so the attacker is in, and they've made sure they can stay in. What's next on the checklist? Their main goal now is to move around the network and gain more power. And to do that, they need the keys to the kingdom, user credentials. This is where the game really, really escalates. Let's talk about a classic power play. Pass the hash. Here's the key thing to understand. On a lot of networks, attackers don't actually need your password. They just needed cryptographic representation, which is called a hash. So they can steal this hash from one machine and then use it to log into other machines, all without ever knowing the password that you type in every single day. So how on earth do you spot something like that? You have to look for strange behavior. Is one user account suddenly logging into 10 different servers at the exact same time? That is not normal human behavior, and it is a massive red flag for a pass-the-hash attack in progress. All right, now for the ultimate prize, the holy grail for an attacker. If they can somehow steal the master key for the entire network, and this key comes from a very special account, sort of the key master of the whole domain, they can forge their own authentication tickets for anything. This is the infamous golden ticket attack. And the result is, well, it's devastating. A golden ticket gives the attacker unlimited, basically godlike access to every single thing on the network, and they can keep that access for years. They don't just have the keys to one room anymore. They have the master key to the entire kingdom. They have become king of the castle. Here's another really sneaky one for you: Kerber roasting. So attackers find these special accounts that are used by services, not by people. They simply ask the network for an authentication ticket for that service, and then they take that ticket offline to their own computer and try to crack its password in private. And that right there is what makes this so dangerous. The attacker isn't sitting on your network trying to guess the password over and over, where they might get caught. No, they take the encrypted puzzle piece, that ticket, offline. And on their own machine, they can try billions of combinations until it opens, and absolutely no one can see them doing it. Okay, so faced with all these really powerful attacks, how does the defender actually fight back? It might sound hopeless, but it's not. It's all about building a smarter, more resilient fortress that's based on proactive hunting and really solid fundamentals. Building a modern defense is not just about buying some fancy new tool. It starts with having the right data. You have to be able to see what's happening on your network. Then you need automation to help you sift through all that noise. And of course, you need skilled people who know what they're looking for. And finally, you need a feedback loop, so you're always getting smarter after every single incident. And here are the defender's big counterplays. To stop an attack like pass the hash, you protect the core system processes that handle passwords. To defeat a golden ticket attack, you have to regularly change the password of that master account, making any stolen keys totally useless. And to defend against Kerber roasting, you make sure those service accounts have incredibly long, ridiculously hard-to-crack passwords. Which brings us to the core reality of this whole field. This isn't a game you win just once and then you're done. It's a continuous, never-ending cycle of offense and defense, of action and reaction, of hunting and of hiding. Let's just come back to this one central idea, because it really captures the entire philosophical shift. Modern defense isn't about trying to build a perfect, impenetrable wall. It's about having the visibility and the skills to find and evict the intruders who will, inevitably, get inside. And that really brings us to the final question we should all be asking about our own networks, our own systems. In this constant, ongoing digital game, are you the hunter, actively out there searching for threats? Or are you just sitting back, waiting to be hunted?